Right, so Pythagorean theorem. Pythagorean theorem derives from, or like the name of it derives from the person who actually was the founder of Pythagorean theorem, which is Pythagoras. And it basically involves the concept of a right triangle and the side measurements, that they have a relationship to it, to where that if you square the leg measurements of a right triangle and take their sum, it should be equivalent to the hypotenuse value squared. And we're going to go over what all of that means, because I'm seeing some faces that look a little bit confused. That would be Confucius, not confusion. All right. So Pythagorean theorem. The idea of it, like I just said, is that you are basically having this relationship between the legs, which forms your right angle, and the hypotenuse, which is the measurement that is across from your right angle. That's its name. And how they relate to each other. This is only true for right triangles. This concept is only true for right triangles. So it's actually a way of being able to identify if a triangle is a right triangle. So we discussed a few units ago how to identify if a triangle was a triangle or not, if three measurements could form a triangle. Now we're identifying whether those three measurements will form a right triangle or not. So again, it's got three sides. Two of those sides are called the legs, and we label them A and B. And then the third side is the hypotenuse, which is what we label as C. And again, it's only of a right triangle. So I'm going to draw a right triangle real quick. So you know the two measurements that are going to form the right angle, those are going to be the legs, always. And it does not matter if you label one of them A and the other one B. They're interchangeable. This could be A or it could be B. This could be A or it could be B. It's just one or the other. So I'm just going to go ahead and label this one A and this one B. It's just, again, it's important to understand that the legs form the right angle. Let's go ahead and actually write that down. The legs form the right angle. God bless you. God bless you again. The legs are what's going to form that right angle. And then the third measurement, you'll know it is the third measurement because of the fact that it is directly across from that right angle. And that is always going to be labeled C, the hypotenuse. So again, that hypotenuse is always directly across from the right angle. And what's also really important to know about the hypotenuse, guys, is that it's always going to be the largest measurement. The hypotenuse is always your longest measure on the right triangle. And just as they were saying up in the front, the hypotenuse, or sorry, the Pythagorean theorem formula is as follows. It's a squared plus b squared is equal to c squared. So like I said at the very beginning, you're squaring the value of the legs and taking that sum, and it's equivalent to the value of the hypotenuse squared. All right. Given the following right triangle, I want to know what the perimeter of the triangle is going to be. So right now, what two measurements am I being given? Say it louder. Are those legs? Leg and hypotenuse? What? The legs. They're both legs. Again, it does not matter whether I label one of them A and the other B. It doesn't matter which one gets labeled A and B. They are both legs because they are forming the right triangle. So I'm going to go ahead and label 12 as my A and 9 as my B. And then I just substitute it into my formula of A squared plus B squared equals C squared. And C is the value that is missing in this case. So instead of A squared, I'm going to replace A with 12, and I now have 12 squared. Instead of B squared, I'm going to replace B with 9, and I now have 9 squared. And again, I don't know what C is, so it stays C squared. It's the value that is missing. What's 12 squared? 144. What's 9 squared? 81. And that's going to be equivalent to C squared. Let's go ahead and add 144 and 81. What do we get? 225. So we have 225 is equivalent to C squared, but I don't want C squared, I want C. So who remembers, based off of our last unit, what is the inverse operation to squaring? Ashita? A square root. Go ahead and make that note. That's the reason why we went through this radical unit. Even though it's not on your final exam, the concept or the idea of it is a square root is the inverse operation or the inverse of square. So if I want to get C by itself, all I have to do is take the square root of it. But if I take the square root of one side, I have to take the square root of the other side. So the square root of C squared gives me C. And what's the square root of 225? 15. Now, one of the common mistakes that you guys, almost everybody seems to be making right now on their the test from yesterday, I told you guys before that if you take a square root in an equation, how many solutions are there? 2 solutions, positive and a negative, because 15 times 15 equals 25 or 225, but so does negative 15 times negative 15. A lot of you, when you took the square root of an equation, you only put the positive answer. You're getting it wrong because there's 2 roots, positive and negative. However, when it comes to geometry, do you think we're going to have a negative value? No. You have to think, because yes, if it's just an equation, you're solving for all possible solutions. But now we're putting it into a different context. It's being involved as a measurement, and your measurement is not going to be a negative value. So you have to make sure you're thinking through your context of it. If it's just a simple equation, then yes, you should be putting down both of the solutions, which most of you have not so far. In geometry, it's only needing the one solution, the positive solution. Okay? All right, so did I answer my question? No, I did not, because what was the question? What is the perimeter? How do I find perimeter? Add up all the sides. So now, for the perimeter, I need to take A, add it with B, and add it with C, and that's going to equal the perimeter. So A was 12, B was 9, and C I just found to be 15. If I add them all together, I'm going to get 36 inches is my perimeter. Don't forget to put your unit of measure. 36 inches. Take the hat off. All right, let's go ahead and turn to page 28, please. It's not really a question. All right. Given the following triangle, what kind of measurements am I being given? Rashawn? Okay, good. So we know that this value right here, the 5, that's the hypotenuse. How do we know it's the hypotenuse again, guys? It's across from the right angle. It's directly across from that right angle, which makes it our hypotenuse, so we're going to label it C. That means that the other measurement that we have showcased here is one of the legs. Does it matter if I label it A or B? No, doesn't matter. Typically for me, personally, I like to go ahead and if I have the hypotenuse, I like to label the leg B, just because it keeps it in a nice order when I'm doing my equation, and that the missing one would be A. That's just my preference. Okay, so again, our formula, A squared plus B squared is going to be equivalent to C squared. We don't know what A is, so we leave it as A squared. We replace the B with 3, so it now becomes 3 squared. And we replace the C with 5, and it becomes 5 squared. What's 3 squared? 9. What's 5 squared? 25. Okay, so just like Austin said right now, he says, hey, we have to do the inverse operation, which is subtraction, because last time both numbers were on the same side, but this time they're on opposite sides. So when it's on opposite sides, you have to do opposite operations or inverse operations. So you have to subtract the 9 from both sides in order to get A squared by itself. So that gives us A squared is now equal to 16. And like I said before, the inverse operation of squaring a number is to square root it. So what will A equal? A equals 4. A equals 4. But I'm not done, because what was the question? Find the area. Okay, so how do we find area of a triangle again, Diego? Okay, so like base times height divided by 2. Half the base times the height. So go ahead and write that down in case you've forgotten that you're just going to multiply your base and your height, and then you're going to divide that answer by 2. So which one of these letters represents the base up here? Austin? A. Okay, so here's our base. So that means what's the height? The 3, B, right? That's our height. Well, we know what A is now. What is A? 4. So we're going to multiply 4 times 3 and then divide it by 2, and that gives us 6. Now this is area, so it's our unit is squared. 6 units squared. If they don't give you a unit of measure, you just write that it's units. Okay, so if it said yards, you would put yards squared. If it said feet, you would put feet squared. But since it doesn't have a unit of measure written, you need to put units squared. Yes? Go ahead. All right, so let's make a quick little note based off of the 2 different types of examples that we just saw. If the hypotenuse, which is your C value, is the one that is missing, then the basic steps are as follows. You square, add, and square root. Square, add, square root. And here's what I mean. So you square the 2 numbers that you know, A squared and B squared. You add the 2 numbers together, or those 2 answers. And then you take the square root of the sum. Square, add, square root. It's just those 3 basic steps. Square the numbers, add them, take the square root. Now, if it's the reverse, if the leg is the value that's missing, so A or B, it's literally the exact same process except for one change. What was the one difference? Subtraction. Instead of squaring, adding, and square rooting, in this case you would square, subtract, square root. So it's a similar concept, square, subtract, square root. So same idea, A squared and C squared. Then you take the difference of the two numbers or two answers. And then you take the square root of that difference. Very similar concepts. Bless you. When you've got that written down, turn to 28. 29. Did you get it? You got it? All right, try these two on your own. If it doesn't say anything about area or perimeter, then you're just finding the missing measurement. Is there anybody absent today? Everyone's here? Okay. who can tell me what they got for problem 3? What's the measurement of the missing side? Howard? 25. So the value that is actually missing happens to be that hypotenuse again. It's directly opposite of that right angle, so that's our C. It doesn't matter which one of these are labeled A or B. Just go ahead and label one or the other. So 15 squared plus 20 squared is going to be equal to C squared. 15 squared is 225. 20 squared. When you add them together, you're going to get. And then what's the square root of 625? Very good. This is why it's really good idea to have your perfect squares memorized. It makes this process go a lot faster if you've got them memorized. So the square root of 625 is going to give you 25. And it's 25 millimeters to represent C. Okay, what about for problem number 4, Skylar? 15 yards. Very good. The hypotenuse is a measurement that happens to be given to you. It's the leg that happens to be missing. So in this case, it's going to be A squared plus 8 squared is equal to 17 squared. What's 8 squared? 64. And what is 17 squared? 289. Okay, and remember, when the leg is missing, you square them, subtract the values. So 289 minus the 64 is going to give us, good, 225. And then the last step is to take the square root of 225 to get the value for A, which is 15 yards. Any questions? It's pretty easy. When you're doing your homework, you just have to make sure that you're reading carefully between whether they want you to find just the missing measurement or find area or perimeter in that case. All right, the last thing I want to teach you guys real quickly is not just how to find a missing value, but also to identify whether these measurements represent a right triangle or not. So you can use the Pythagorean theorem to identify if 3 measurements are a right triangle indeed or not. Honey, I'm in the middle of class and you're talking. You come in and you come in silently, otherwise I don't ever let you go out again. Identify the right triangle, if it is a right triangle or not. 18, 30, and 24. Those are the measurements I'm being given. So now I need to plug them into my formula to see if it's going to be true or not. But before I can plug them into my formula, I have to find out which one's supposed to be A, B, and C. But remember, I told you guys at the beginning of the lesson, how do we always know what the hypotenuse is? It's the longest measurement. So all you have to do is look at the 3 values and identify the largest measurement. Which one's the largest? 30. So automatically right here, that value is going to be your C. The other 2 values will be your A and B. And you just check to see if you plug them into the formula, is it going to be true or not? So we have 18 squared plus 24 squared. We want to know, is it equivalent to 30 squared? What's 18 squared? Quick, come on, guys. 324. 24 squared. 576. Now 30 squared wasn't required, but that's an easy one. It's what? 900. Okay, so if we add 324 and 576, is that going to equal 900? Yeah. So 900 for the sum is equivalent to 900 for the square. So since they are equivalent to each other, yes, this is a right triangle. Check this one on your own. All right, is it a right triangle? No. What's the largest measurement? 7. So there's your C. The other two measurements are going to be your A and B. So if we do 5 squared, which is what? 25. And then 4 squared, which is 16. And add those together, we're going to get 41. 41 is not equivalent to 7 squared, which is 49. So they are not equal to each other. Therefore, it is not going to be a right triangle. Any questions? Okay, so you have an assignment on this material today.